Due to technical difficulties, namely I forgot to turn on the audio recording, the first 3.5 minutes of this talk don't have sound. On the bright side, you didn't miss much. Everything is on the slides. You only missed some of my jokes, but maybe it's for the best. In any way, just read the slides and the sound kicks in 3:30. For those joining us with sound now and watch the video, you should look through the slides. It has everything that important that I have to say, minus the jokes. So it is what it is. Right, so we spoke about how this is a great simplification to problem of dependencies, but the problem with the problem of dependencies is that it's very hard to simplify in a way that will be sufficient. And this solution, although it was simple, had and worked for Google when Go was a language inside Google, have a couple of very big problems that were ignored back in time, not because people were evil, but just because it wasn't supposed to do anything except of the problem of Google, which it solved. Right? So there are a couple of questions that it's very hard to answer if we use the dependencies as we use them, right? So for example, know which dependency do I use? How do I know? So I have some folders in my GoPath tree. How do I know they correlate to a dependency? How do I know which dependencies did I use? Right, so for example, if I have now a dependency, how do I know which version was it of this dependency? How do I know which dependencies I should use? Where I can discover the libraries, the third-party open source libraries that I can use, and how should I use them? How do I know if it is our code in terms of the code of our organization that I edit? So obviously package declarations can help. If I see a package declaration which is outside of my organization, I can assume that it's not our code. But how about internal dependencies? If there is another team that does development and I consume their code as a dependency, how can I determine if that's a dependency or my code? Right, so generally it's a mess because even if you look at your code 6 months from now, what are the chances that you will be able to recognize it and not confuse it with a dependency of someone else? So Dave Cheney, he's a big name in open source Go ecosystem. He wrote a lot of great tools, and this is his testimonial back in the day when he had to use go-dep like in a normal way of dumping all the dependencies in the source tree, right? They resorted to email semaphore to alert not to touch something. And you obviously can guess how well that worked, right? And obviously people asked about that, the Go team in Google. There was panels that it was discussed, there was interviews that they were asked, and the answers of the Go team were, how to put it mildly, insufficient, right? So here's, for example, Brad Fitzpatrick say, well, duplicate your dependencies. Take the dependencies from someone else's version control and check them in your version control, which we're going to talk about. This is vendoring, and it's a really bad idea. Or here, Andrew Jern says, build your own dependency manager. It's not a role of tooling to provide by the language to dictate how you manage your code in production sense. We're not going to build a dependency manager for you. And here he keeps saying, okay, use something that's already there. Like, for example, Git, Mercurial, or Bazaar. That's an old interview, obviously, because 2 or 3 of them are dead by now. And I mean, you know those tools, use them as a dependency manager. And then again, Brad, well, we have go-get, which is kind of a dependency manager, but if you do something serious, don't use it. So, I mean, if those are the answers you get from the team you rely on to provide your tooling, next thing you know, there are 19 dependency managers from the community. And 19 here is not like a number to say there's a lot. There were actually 19 dependency managers that I at least could find. And it's a good thing and a bad thing. The good thing is obviously the community is there to step up when the creator of the language falls short of providing something that we need, but it also obviously generates confusion, segmentation, intercomparability issues, and what's not. So, are you familiar with any dependency managers for any Go modules? Let's test it. Quiz time. Okay. So go-deps.json. Anyone knows which dependency manager uses this format for describing dependencies? It's called go-dep. The reason why the file is not called go-dep is because dependencies TSV actually it's a descriptor for a dependency manager called go-deps. Okay, out of govend, govend, goven, and gv, which are real dependency managers? All of them. Trash, garbage, and rush. By now you want to say all of them, but no, only trash. Trash is the dependency manager by those guys. I keep forgetting their name. They do stuff around Kubernetes and develop this tiny K3s for embedded devices. Yes. No. It's like Keep forgetting that. Sorry about it. Huh? No. You should know. K3S, the tiny Kubernetes for embedded devices. No? Okay, someone please Google Crash and Go. I want to give them credit. They're very Rancher. Thank you very much. Yes, Rancher. Right. So and okay, weapons manufacturer. This one is easy. Glock, like Go lock. Right. So it is a lot of fun, and obviously. All of them use the concept which is built in by the name called vendoring, right? And vendoring is about, okay, we create a directory when we are going to keep the dependencies, and it will be separated from where we keep our source code, right? So we'll just make a copy of the source code and put it in a separate directory, and then our tool will know to copy them into GoPath for cross-compilation during the build, right? So that's the idea. And vendoring sits very well on GoPath solution because that's about it, right? We use a monorepo, which is again one of the concepts of Google, which was promoted, which is still promoted very heavily by Google and other companies that it works extremely well for them. And the idea is that you have one repository for everything. And that's what GoPath is. It's one repository for all your Go sources and all the dependencies. And vendoring sits very well in this concept because when we need to compile, we need to take all the third parties, dump them into this single repo, and then we compile everything together and everything will work, resolving by imports. So it works very well with GoPath, but GoPath is not, GoPath and monorepo is not for everybody. There are two very big problems with GoPath. It only allows one version of any given package to exist at one time, obviously, because the names of the Go files, of the Go packages, are not versioned. And if I have one copy of a Go file of a certain version, I cannot have the other one because it will have the same name. So that's one problem. And the other is it has something to do with what we spoke about earlier. We cannot programmatically differentiate between code the user is working and a code they are dependent on. Well, sometimes we cannot humanly differentiate as well, but programmatically we never can. So, most of the other languages use different approach to that problem. And we use Java, JavaScript, Python, Ruby, .NET, take any language. You have an arbitrary folder for your project, which can be a part of monorepo, but also can be a standalone. And then you bring the dependencies in, it's a workspace of its own, and that's what, proven by our experience, is a more flexible way to do it, right? So, talking about vendoring, just to remind you, vendoring, you take the source code of the third-party dependencies, and you make a copy of all those sources into your version control. It is actually a fork, but it's a very bad fork. Because, first of all, you lose all the history, branches, and tags of the dependency. You copy to your version control, and it starts a new life, like it didn't exist. You cannot pull any updates because your fork is completely disconnected from the original fork. In the end of the day, you will diverge because you discover some bugs into this third-party code, you want to improve something, and you go ahead and start working on it, and the connection between the whatever is master of this dependency and your modifications is lost forever. You actually double the space taken to store them because they're stored once there and you store them again. That's the least of the problems, obviously, because storage is cheap. But obviously, the biggest problem is good luck finding which version of the code you store. And this is actually horrible because you actually don't know what you depend on. You depend on some arbitrary commit that is completely detached and you have no idea what you're looking at. So there is a way to overcome some of those downsides. Anyone wanna name it? Well, it didn't work. Usually it works because someone usually comes and says, yeah, we use submodules. Who are familiar with Git submodules? Okay, anyone loves Git submodules? Yeah. Right, so submodules is a nice solution to keep the relationship to the original source, right? So instead of doing a fork, you point to the other repo, which solves some of the problems, but you still have no idea what version are you using, because you checked out something and it's just there, it's not versioned properly. You have to connect each dependency as a submodule manually. There are some tools out of those 19 that can do it for you. You declare dependencies, they will go and connect it, but still, it's a different connection for each and every dependency. And obviously, all the horrors of Git submodules, we have them at full. Switching branches, and obviously working on modules with other teams when your repository is a submodule for them and their repository is a submodule for you. That invites a lot of fun in Git. So basically, this also sucks, and it looks like there is no easy way. And here we are, 10 years after, and we're like, okay, now what we do? Because we want better dependencies, but there are concepts which stand in the way. Go path, versioning, etc. So what Go creators did, they started experimenting. And the experiment is known as the go-dep experiment, and it was run for a couple of years, led by this guy, Sam Boyer, that wrote a blog post describing his experiences. So you woke up this morning, rolled out of bed, and thought, you know what? I don't have enough misery and suffering in my life. I know what to do. I'll write a language package manager. And then he goes into the details why package management is awful and you should quit right now. And those reasons include software is horrible, software is terrible, people are terrible, there are too many different scenarios, nothing will really work for sure, it's provable mathematically that nothing will really work for sure, and our lives is meaningless perturbation and swirling vortex of chaos and entropy. Of all people, we at JFrog feel Sam, and we know what he's talking about because we deal with dependency managers for more than a decade now. We have our own dependency manager for C++, named Conan, and obviously we provide support for any other dependency manager in our repository manager and central repositories and what's not. So when I read it, I was shivering because that hit very, very close to home. And I have to admit, he is absolutely right. Dependency management is a very, very nasty business. But saying that, Sam actually came up with a very, very well-built dependency management, the proper dependency management for Go. So we switch away from Go path. We work in project directories. We have local cache for dependencies when they are downloaded as artifacts and stored there. We have version declarations on dependencies. It's not a random commit in someone else's source code. And we have a proper conflict resolution, or not proper, depends who you ask, but we have a conflict resolution, and then it all blown up. It blown up when actually Russ Cox came with alternative solutions. And there was like a very big fight over a couple of concepts, which I have in the show notes, but I don't see now. It's basically some stuff about how to resolve conflicts, how to resolve versions, and also some personal branch on who was there first and who had a bigger dependency management and all this kind of stuff. It's all linked in the show notes. so you're more than welcome to go there and read both sides of the argument. But since Russ Cox is writing Go, he won. And now we're entering the Go module. Go modules was a rewrite, like a completely new project, not relying on go-dep, but using a lot of the same concepts. First of all, how it works. If you are a user, what do you do? So what you do is you go into existing Go project or a new Go project, but let's say existing around this more challenging, and you type go mod init. When you did that, go mod, which is a descriptor of your dependencies, is created, and then everything just works. You add imports in your code, you run go build, and it just works. And obviously that's some serious magic, and this is where I take my hat off, because doing a backwards compatibility, transparent backwards compatibility for a decade of community-driven development ended up in 19 dependency managers is a very, very serious magic. So the way it works is that the Go now has a converter for almost any dependency manager that was created during this time, at least the popular ones, and it will create the respective Go mod file, including all the information, all the metadata from those different dependency managers. So it will take the Glock file, will parse it, and will dump it into Go mod. And if you don't have that, but instead you have Glide, it will take the files from Glide and put it in Go mod. So basically they do all the work of converting for you. And when you add new dependency, you just add an import. And then when you add an import and then run go build, let's see what happens. So I have no idea why this slide goes from right to left. It's probably some kind of an Israeli thing, but it is what it is. Right, so you add an import, and then Go checks if it is a version control path. Usually it is, right? You go like github.com/username/ the repo. It will be usually a version control. If it is a version control, it will be cloned by using git clone, actually git clone command, and then it will be built to a module, and a module is an archive of package or more than one package, version archive, and then it will be saved in your local cache. As I mentioned, now we have local cache, and then served to the compiler to compile everything with it. And this is just archive of sources, so during the build, it will be unarchived and build everything together. Now, if it is not a version control, it might be a web page, like a really HTML page. If it's not an HTML page and it's not a version control, then it's an invalid import. If it is a web page, if it is an HTML page, we will look for a meta tag in the HTML code, which is called go import. Go import should have a URL. And this URL might be a version control or anything else, right? And you probably know both scenarios. Sometimes you import like github.com/whatever, and the other time you import stuff like what it's called, Go. Yeah, packagen or this kind of stuff. There are a couple of websites which will have the documentation, but not the origin, but not the files themselves. And you wonder, okay, how do we actually get the files if it's only the documentation? This is how. It will, if you look at the sources, you will see there is a go import meta tag that actually points to the real version control of the file. Okay, so this is how it works, and then it kind of becomes more clear. Okay, I write import, I know what happened. It will clone it, and then it will serve it to me. Now the only question is if we talk about proper dependency management, is how is how the version is selected. Because what we have now, when we have a proper dependency management, we have versions of my dependencies. Now, in the import declaration in Go syntax, there is no version. I'm not relying on a specific version of a package. When I import that, instead I just go like import this thing. Now, obviously there is some sarcasm here, because selecting a version is never easy. This is where it's mathematically proven that nothing works. But as in a lot of decisions in Go, we opt for a simple solution and then hope that everything will just work, somehow sort it out. And here, what Raz did is the same. Let's take the latest compatible version tag. So when I put an import, I will rely on the latest compatible version. Well, you go like, what does it mean, latest compatible version? How anyone knows? And the way that it's sorted right now is pretending that samware actually works. And that means that we make the assumption that the latest version of 1.x.x is compatible all the way to 1.0, which is how samware supposed to work, but we know in real time that it's not always that way. And this is the heart of the debate between Sam and Russ about should we assume that or not. And obviously Sam was no, that it will never work, and Russ was like, yeah, it will probably never work, but I want people to be responsible, so if they broke other people's build, let them fix their shit, basically. That was like kind of two approaches. And what we are now is this approach. We assume that samware works. And that means that when we do an import, we actually we assume that import path always backwards compatible. Because you remember we take the latest version, the latest compatible version. So if we do an import, it will go to GitHub, it will see the tags, it will pick the latest tag, the rest of the released tags, within what should be compatible in samware, which is a major version, right? Next question is, okay, major version, it makes sense, it should be backwards compatible. What happens if we bump the latest version? How Go will know that I want the latest tag in version 2 instead of the latest tag in version 1? And the answer is, you need to tell it. We decide that incompatible code shouldn't ever use the same import path, because we assume that everything in import path compatible within the range. So we need a different import path. We add version 2, we add version 2 and import, like that, import my module, version 2, my package, and now we are in completely different path, right? So for the machine, this is a unique string. It doesn't know that v2 actually means same thing with version 2. For the machine, it's a unique string, so it will do the same. It will go and look for the latest tag within the v2 range of tags, because now it's completely separate. So again, I admire the simplicity of it. It's brilliant, it's super simple, it's super understandable, except of when samware is not compatible. Which, blame it on humans, but it is what it is, right? This is why dependency management is so nasty, because you design everything well for the machines, and then humans come and mess up with everything. So, another scenario is You want to rely on my code, and I didn't do any tests. Easy, right? Before Go modules, that was like normal. No one required me to create a version if I want my code to be used as a dependency, right? Because anyway, we just pick a random commit and then grabbed it to our vendoring, and no one cared if that's a version or not. But now we spoke about sender works, so we need versions. What happens if there are no tags? If there are no tags, a pseudo version will be created. A pseudo version will be one below the existing tag. So if I have no tags, it will be version 0. And then it will include the timestamp and the hash of the commit. Now, this pseudo version is not compatible with anything else, because if I didn't release, I didn't assume any responsibility of compatibility, so you can't expect this tag to be compatible with anything. I can break whatever I want, whenever I want. So there won't be no conflict resolution in case I have a transitive dependency conflict. Because if I have two dependencies that depend on different versions of the same module, if I use sender, it will be picked correctly, the latest will be picked, and the former will be expected to be compatible. But if I have a transitive dependency problem and I only have pseudo versions, the build will fail on transitive dependency problem, which cannot be resolved because there are no compatibility guarantees in version when I don't have a major version. So this kind of a migration solution that is created now for us to be used with dependencies which doesn't have tags, but obviously the community is encouraged not to use pseudo versions, to push the creators of the modules that we want to use to actually version properly, take responsibility for backwards compatibility, and start creating proper versions. But for meanwhile, this is kind of the solution that actually works. So, for example, in GoCenter, we're going to talk about it in a minute, it's like the source for dependencies. You can select in search whether you want to see modules with pseudo versions or not. You may decide, I don't touch that. Unless people take responsibility and create proper versions, for me, this thing is not useful. Right? Okay. And honestly, we are now to the problem of, okay, the compatibility promises of firmware is violated by pesky humans that have no idea how to write proper code. So now what do we do? When we need to ban a dependency, this actually is very simple. You can specify, I only want to use version X or later, and if there is a conflict, it will fail because the compatibility is broken. Or you can specify that you want to exclude a certain version. Every version in the range of my tags are fine except for that. Or replace. Every time someone asks for this version, give them that version instead. You can also replace it with the local file that you have on your machine. And I encourage you to forget that this feature exists, because this is how works on my machine problems create. So those are the tools that you have in order to fight those broken sender promises. It will obviously require for you some time to debug and understand what's going on. The good news are it will be much easier to find them comparing to Maven. Anyone? Or try to resolve dependency conflicts in Maven? No? No? Well, I used them there. Yeah. And why it will be much easier? Because every time you build with a new import, Go will add to your Go mode not only the dependencies that you added, but also all the transitive dependencies that come with it. So just by looking at your Go mode, you will see the list of all the dependencies that you use, either directly or indirectly, and this obviously makes your life much, much easier. Okay. So, with that, let's talk about another problem that now we have. So once we gave up control on the sources of our dependencies, and we stopped this bad practice of copying them over to us, we might develop an anxiety of what happens if suddenly my dependency is not available. And it is a big problem, and it's a legitimate problem. And this is where we actually enter, again, a new concept, which will replace rendering and guarantee that you don't have this problem, and that's a hierarchy of modular repositories. So one of the premises that is extremely important in dependency management is that modules should be immutable. In terms of module at a certain version should always resolve to the same code. Whenever I call my user my repo version 1, it should return the same set of files, the same artifact with the same content, always. Today, in half a year, in a year from now, in 10 years from now. Right? They should forever be the same. But if we rely on sources in Git, on GitHub, this is not the case. Because the versions are tags, and tags are mutable. You just add a small -f, and your dependency under the same version have different content. More so, someone can just, we'll come to that later. So the way you solve it is you go through a repository. You go through a cache that will cache the dependencies that you use, and will guarantee that every time you ask for the same module, you will get back the same file because it's cached there and it's not going anywhere. The way you do it is you use environment variables called go-proxy. You point it to your repository, and then when you run go-get, go-build, go-tidy, whatever you run, all the dependencies will be resolved from, not directly now from github.com like we saw in the previous diagram, but it will first check the proxy. And the way it works is, that's our same diagram. We access the import path as URL, and now we will check if we have this go proxy setting. If we have go proxy setting, this is where it will be checked. If there is a module there, then we will just serve the module. If the module is not there, then it will go through the same process. Right? So basically, we will have another step that will check the go proxy, and it will check if there is a module there. And this is actually awesome that we have this repository, because now we have a hierarchy of 3 different types of caches. The first is the local cache. It is in GoPath. We found the proper usage to GoPath now, and it's not keeping the old sources, but it's just cache for our repositories now, cache of our modules, because our projects are now in separate directories. And obviously, it gives you immediate access. Your build will be super fast. It won't even get to the internet to resolve dependencies if you have them on your machine. But those caches are not shared, and they can be wiped, and basically cannot be relied on, and it works on your machine. The next level is organizational cache, and that will be your organizational repository, something like JFrog Factory that supports Go modules, and you will point your Go proxy to your JFrog Factory setup. Artifactory is not the only organizational repository that supports Go. There are Project Athens. It's a community project led by Aaron Schlesinger that I quoted, and he's from Microsoft, but it's an open source and very open project. It only does Go when JFrog Factory does everything, but it's free and open source. But I brought the t-shirts. So JFrog Artifactory, yeah. Generally, this class of repositories gives you fast access, but requires either infrastructure or an account in cloud provider. So you either install it on your prem, and then it will be like some servers to run, or you take it from AWS, GCP, Azure, whatever you want as a service, but then you obviously pay for service. And the third level of caching is JSON or Go Center, and that's a public cache. It contains, I think we're now at 100,000 modules, and it's highly available. It gives you CDN, content delivery network. It's free, you don't need to run anything, and then this is the one you use. So the way it works in your configuration, local cache is also always checked. You don't need to do anything to work with it, because this is how Go built. Now, if you use organizational cache, you point your Go proxy to your organizational cache, and it is smart enough to know to go to public cache for an upstream. If you don't have Artifactory or other, or don't want to use it, you can point your Go proxy directly to Go Center or other public repository, but then obviously you will only have what is there. You won't be able to share your own modules without making them open source and putting them on GitHub and then going through Go Center, etc. Right? So those are your options. Generally, with any serious development, you will use all three of them, setting Go proxy to this guy. Right? Make sense? Okay. I have to say that there are others public proxies. In Go 1.13, the default public proxy is actually set to the one that Google came up with, just because they own Go, so they can do whatever they like. For example, promote their own services through their own tools. For some reason, I remind that they didn't really like it with Windows and Internet Explorer, but somehow with Go and the repositories, they don't really care now. That's weird. That sounds like double standards. Anyway, it's good that I have the disclaimer, right? Anyway, it is what it is. If you want to do anything, if you want to use their public proxy, you don't even need to set Go proxy anymore. Starting 1.13, it will just use that. If you want to switch to other one, I almost said a better one, then you go set Go proxy to gocenter.io and you use Go Center. And I will try to convince you why you might look at Go Center a little bit later. So, in the end of the day, this hierarchy of caches, what it does is create immutable and repeatable views. Because you have immutable dependencies, and because they will, whatever happens inside the tag is not relevant anymore. Once it's built one and cached in all those repositories, they can do whatever they want with their tag. And it also protects you from loss dependencies when someone, takes their shit and goes away, and now your build won't run anymore because the remote dependency does not exist. This cannot happen now because we have the caches, and it obviously provides you with protection against internet issues, GitHub is down, or whatever, because unless you add new dependencies, you work with your local cache, and even if you add new dependencies, there is a high chance that it will come from your organizational cache, because someone else in your organization already used it, and then again, you don't need access to Go Center or whatever Google repository. So this is a very good thing. It works out of the box, and you just need it. Also, obviously, faster builds. You remember the previous diagram in which we had to git clone the sources, not a very fast procedure, create an artifact, and only then we can use it. Now, if you use Artifactory or Go Center, you just download pre-archived module. And go-get is much faster than, HTTP get is much faster than git clone and zip. And here we're coming to more like on discussion about what a central repository like GoCenter can be useful more than that just a headless cache. Because generally, if you use this cache, you don't really care. Remember how you work with it? You do set go proxy, or you don't even do that, and then you add imports, and it just works. You don't really care what this URL goes to. I'll tell you more. The Go repository of Google, they don't even have a UI. Right? So it's not, you're not intended to go there and do something. And here when we come and try to compete with what's built in by default, obviously we will try to provide more value for you. So one of the things that we already have is if you go to gocenter.io and search there, you can pick the right module because the documentation is right there already, so you can browse it and decide if it's good. There are some statistics for you to understand which package is popular and which is never used, right? How many downloads, how many stars, this kind of stuff. In the future, we plan to introduce stuff that will be easier for you to nudge the authors to do the right thing. For example, if you use a module with server version without a release, you can, by a click of a button in GoCenter, create an issue or +1 an issue that asks the author to properly version their module. Right? Ratings. This is something that I feel very passionate about, again, because I'm judgmental. So I want to judge modules and I want to say this is a good module, but this is a bad module. And for ratings, I think it has a value as long as it's very transparent how do we judge? What are the factors? And we came with a formula that is open source, so you can, create any issues against it, a pull request against it, and decide if it's good or not. And it has stuff like, does this module have a documentation? If it does not, that's like, you lose points. Is it active? When was the last commit? When was the last release? The last fact, right? Number of stars, that's kind of a vanity metric, but on the other side, it is a standard of today for voting for, yeah, that's a good project in a way of star. So it's kind of relevant. Unit test coverage. Well, from one side, why do I care? Because it works. From the other side, if there is a significant problem that I need to be fixed fast, if there's not a good unit test coverage, I know that release will take time. Right? Unit test coverage gives me confidence that this project can release very fast because they can rely on their test and backwards compatibility. Licensing, this is important. There are good open source licenses, there are bad open source licenses. And it's kind of known now what are good and what are bad. MIT is great, Apache 2 is great, GPL, LGPL, and there are a bunch of others, right? So we can judge by that as well. A number of dependents, how many projects, not only how many downloads this this project has, but from GoCenter, but also how many projects in GoCenter, considering we have the majority of them, actually depend on this module, so we can decide if it's popular enough. Passing unit tests, that's obvious, not only having unit tests but also passing them. Number of forks, this is also kind of good way to measure popularity. Number of maintainers, that's the buzz factor right there. If there is one maintainer, that's a big no-no, stay away, because they might, just give up on the project and then you fucked up, right? So more than one maintainer is good. And recursively the score of the dependencies of this module. Because obviously the quality of the dependencies directly affects the quality of the library that you are about to use, right? So with that, we can now come up with score, and it will be like A+, A, all the way to C, I don't know, D, F, whatever. And obviously the score is not enough for you to pick, because there are other considerations, like for example, if it does what you actually need, features that you are looking for. But it's like with, how do you call it, consumer reports, right? So for consumer reports, you are not going to blindly buy the washer machine that has the higher score, but you will be able to say everything below 60, I won't even bother to check, right? So this is, the idea here is the same. So when you look for your HTTP client library that you need, you can say in GoCenter, only show me the packages which are above C, which are ANP. And then I will do my research, I will compare features, I will decide which one I like best, and then use it. But this will give you kind of a broad figure of what not to use, and obviously when you go to a page of a module in GoCenter, you will see this grade, and you will be, and all the details of how we got to this grade, and you will decide whether you want to use it. So all that is for making you actually go to gocenter.io, to jcenter.gocenter.io, and check if there is additional value. Now, obviously, there will be the amount of music. Right? Yeah, security. So I don't know if you're familiar with JFrog X-Ray. JFrog X-Ray is a security analysis tool that checks with different databases if there are security vulnerabilities in dependencies that you use. It takes the identifier of the dependency, and we just spoke how in my module at version 1 is always the same thing, and then checks if this my module version 1 has any known vulnerability. And we do it for Java, for JavaScript, for .NET, for Debian, for everything. And now, thanks to Go modules, we can start doing it for Go as well. Because now we have those discrete units that have immutable content that we can start and first populate the security databases with them, and then query those databases to check if they have security vulnerabilities. So this is also something that goes into the rate, and obviously significantly affects the rate. Number of downloads, yeah, we spoke about that. So with that, that's all I have. Thank you very much. Just to remind you, jfrog.com/show notes. Baruch now, I'm sure you're going to follow me. And Charlotte Golang, I don't know if this meetup has a hashtag, but now it does. And GoCenter.io is where you go and check and start using GoCenter. With that, thank you very much. Questions?